This will be the last video of the land use portion of the review packet, and it's going to cover mining, and then we're going to move on to fishing. So let's take a look at mining here, and the first question asks you to explain where you find large reserves of coal, oil, and natural gas. Let's take a look at coal first. So you'll notice that the majority of coal ends up being right here in the northern part of the world. There's a large coal reserve in Australia, and actually Australia has a massive coal mining industry that has come under some scrutiny recently, but the majority of coal reserves are going to be in the north, especially in the central and eastern United States. You'll find a lot of coal mining, especially around Pennsylvania and Indiana, around the central and eastern part of the United States. Russia has a couple of coal reserves up in the northeast region of the country, and then of course there is a sneeze because I'm allergic to everything. Let's take a look at oil reserves. The two largest oil reserves are going to be in Canada and the Middle East, with Russia following a very quick third place. So those are the majority of easily accessible oil resources in the world, but it goes the Middle East number one, followed by Canada, and then followed by Russia. There is some oil reserves up here in northern South America, but they're not specifically easy to get to, so it's not particularly talked about in like the global oil economy. But the Middle East, Canada, and Russia are major oil suppliers, and then natural gas. So more or less the same. Natural gas supply comes from shale. So wherever you find large amounts of shale oil, so this map actually does double as a map of shale oil, you're going to get some natural gas. So again, it's going to be the Middle East, the United States, and Russia that has quite a bit of natural gas resources. So let's take a look at all the different ways that mining is done. Open pit mining. It's literally what you think it is. You dig a giant hole, and that's where you get your materials from. And there are some consequences to that, right? Especially habitat destruction, runoff, and acid mine drainage. The usual culprits we know when we think about mining. This is what it looks like. It literally is digging this giant deep hole into the ground. So that's open pit mining. Then let's get into subsurface mining. And this is what we think of when we think about coal mining, right? We're underground, so you're digging tunnels to get minerals that are under the earth. A lot of the dangers of this, because you're digging under the ground, so you're not really destroying, above ground habitat, right? You're still disrupting subterranean habitats where a lot of insects and burrowing animals make their niche. But nonetheless, a lot of the consequences for that are going to be human health impacts, right? Fires, long-term exposure to dust leading to black lung, arsenic exposure. So a lot of those are going to be human side effects. And of course, we have this idea that you have this giant machinery that is tunneling underground. Strip mining. Strip mining is kind of like open pit mining, but you're not really digging a hole as you are digging around stuff. So it utilizes large machinery to remove large chunks of the surface of land in like these large strips. So here's kind of what it looks like. Here's what I mean. We remove materials in like these long lines. We use shovels, bulldozers, large machinery to do that. And of course, the usual culprits: erosion, acid mine drainage, and habitat destruction are the environmental consequences of strip mining. Mountaintop removal is when we literally blow up the top of a mountain to remove whatever is in that rock. So, I do have a picture of it. Oh yeah, I do have a picture of it right here. You take these mountains and you're literally blowing up the top of them. It's kind of depressing to look at, but that's mountaintop removal. Mountaintop removal and strip mining are considered the most dangerous forms of mining. And by dangerous, I mean to the ecosystem. They are the most destructive forms of mining. Mountaintop removal, especially because it really adds to sedimentation into nearby rivers, which is causing a whole bunch of heavy metals, right? Especially arsenic and mercury to accumulate into nearby aquatic ecosystems. Both arsenic and mercury bioaccumulate and biomagnify, so they not only affect organisms higher up in the food web, but they also affect consumers like us who sometimes like to purchase fish. And then drilling, right? That's you're drilling to harvest oil, natural gas deep into the ground. And oil spills are like the big side effect of this. We all know them. Oil rigs look like this, but that's only the top. These go all the way into the ocean, which is very deep. So I mean, it's extravagant to think about exactly the sort of engineering ingenuity that went into building these. Nonetheless, they are very disruptive, they are very destructive, and oil spills are very toxic. The chemicals in the oil are toxic, but also you're blocking light from producers and aquatic food webs. So it's got like a two-hit badness to it. This is one of those FRQ questions that you think you're answering broadly. I mean, you think you're answering specifically, but you're not. Mining causes pollution that may disrupt the environment. I mean, that's a true statement, but you haven't really said anything. What kind of pollution, and what do you mean by disruption in the environment? So here I sort of improve the statement a little bit, right? So mining uses acid, which may contaminate nearby ecosystems when it drains out of the mine. So here you have a very specific type of pollutant, right? You're talking about acid mine drainage. This can change the pH of nearby water, reducing it below the tolerance of aquatic organisms. So here you have a specific effect, right? These aquatic organisms are being put outside of their ecological tolerance with the change in pH. But I'm also adding one more. This drainage also contains heavy metals, which can be toxic, like lead and arsenic, and both of those are potent neurotoxins. So this is a much better way to say this statement. Moving on. What laws prevent mining issues, such as acid drainage and the displacement of tailings, right? Tailings are those byproducts of actually smelting the ore. Well, that's CERCLA and RCRA. So CERCLA is Superfund. That's the thing that provides federal money to clean up contaminated sites. And then there is RCRA. So RCRA is the actual thing that says you must mediate the damage you do. You must track the products you make from cradle to grave. So RCRA is like the prevention law. So this prevents massive contamination and pollution issues associated with the environmental degradation of mining. And then CERCLA. And this is kind of like the cleanup laws. These are the ones that, all right, if something is messed up, who is liable and how is it going to be cleaned up? So those are the two laws that prevent issues. Fishing. So the technique that is used to harvest scallops, crabs, and shrimp from the seafloor is called dredging. So the way dredging works is you take this giant container and you literally just dredge it across the ocean floor. This is a little different than trawling, which we'll talk about in a second. Trawling uses nets. Dredging uses these large containers. And dredging is considered more damaging. Dredging really disrupts the floor of the sea or a lake or an ocean or wherever it is you're fishing. It really disrupts that, and it can really damage the fragile ecosystems that occur here at the bottom of whatever body of water you're looking at. So dredging, environmentally speaking, is considered the most damaging way of fishing, especially when you're looking at the bottom of an ocean. Then there's trawling. Trawling uses nets. So it's not considered as damaging to the actual physical environment, but this is non-discriminatory. So one of the issues is you don't exactly know what kind of fish you're catching. The good news is fish usually travel in schools, so when you see a large clump of fish, they're usually all a population of the same species, but still you get this issue of bycatch. And bycatch is one of the largest issues in fishing. It produces a lot of fishing waste, and some of those species that get caught in these nests are endangered or at risk of becoming endangered as a result of fishing. Then there's longline fishing. And longline fishing is just another thing where your big issue is bycatch. You are indiscriminately catching whatever decides to, well, clamp onto your lures here. These are all different ways of fishing. They have slightly different environmental consequences, right? Dredging physically damages the bottom of the ocean floor. Trawling catches large amounts of organisms, and bycatch is a possible option. And then there's longline fishing, which also has the bycatch issue. The main difference in environmental effect is trawling. It's easier to overfish. With longline fishing, you're not using a giant net. You're not catching as much as you can. You're catching whatever attaches to the lure. So when we think about overfishing, we usually imagine trawling being the most or at risk of causing an overfishing issue. Well, why is overfishing such a difficult issue to solve? And that's a socio-political question, right? So much of that is about the seafood supply chain. It's about the demand in the industry. Remember, the majority of the world gets its protein from fish. We're pretty unique in the United States, where we eat a large amount of chicken and beef, whereas the majority of the world gets its animal protein from fish and fishing. Not to mention, a lot of fishing that's done is done by poor subsistence farmers. So when you go to low economically developed countries, a lot of people make their living through fishing, and they want to make as much money as they can in these impoverished nations. So this is a large global socioeconomic question. But what are some things we can do to prevent overfishing? Well, number one is control the number and size of fishing vessels. Do not allow large fisheries to go out into the ocean in large numbers to catch as much as they can. Make sure that they need to get permits and that there are regulations based on how large your net gets to be and how many fish you get to catch. Set up habitats, so protect critical areas from fishing. Set up aquatic nature preserves, much like we have national parks to protect terrestrial ecosystems. There are ways that you can set up these protected areas, especially around coral reefs and other endangered critical ecosystems, to prevent fishing from happening there. And of course, require catch limits. Make sure that whether you're just a hobby fisherman or if you are an industrial fishing company, make sure that you're not running into a tragedy, the commons issue, right? Make sure that whatever every single company or entity that is fishing is doing actually ends up being sustainable. Now, let's move on to the pros and cons of aquaculture. So aquaculture is fish farming. So you're not going out and catching fish. You're setting up areas along the coast where you literally farm the fish. So of course, you get to meet consumer demand a lot easier. You don't have to go out and fish. You already know where all the fish are, right? This prevents a lot of overfishing because you're not contributing to the decline of fish in the ocean. This is your own fish that you grew, raised, and farmed. However, sometimes fish escape. And think about farms. You have fish in really close proximity to each other. That increases the risk of disease spread. So fish farming, aquaculture, increases the risk that a diseased fish from one of these fish farms will introduce diseases into wild populations. And then, of course, you run the issue of lowering genetic diversity, right? If you're fish farming, you're probably only raising one type of fish at a time, which lowers the local biodiversity. And then, of course, the runoff, right? These fish are producing waste. They're all in a concentrated area, which may lead to eutrophication, which can change the water quality, which can in turn affect the areas around your fisheries rather than just your actual fish. And to wrap up the relevant laws and treaties that prevent overfishing, the important American one is the Magnuson-Stevens Act. And it's really there to protect federal waters from overfishing, to rebuild fish stocks, and to increase the economic and social benefit from fishing. And it really does that in two ways. Number one is it sets standards for fishery management. So if you are managing a fishery, what relevant safety regulations must you have in order to protect your employees? And in order to protect the fish, we looked at establishing annual catch limits and accountability measures. So how many fish can you catch? What size of each fish can you catch? And that's really the, at least the American law that regulates the fishing industry. The last part of this unit packet that asked about the global bank is no longer part of the curriculum. So why bother going over it? It's not important. It's not going to be on your exam. I've recently started drinking LaCroix. This one is watermelon flavored. And by watermelon flavored, I mean the LaCroix truck probably at one point drove past a watermelon truck, and that's how the flavor got there. That's it. There is no more video. You can stop now. Fade to black.